Good morning, guys. So today we're going to talk about multiplying monomials by polynomials. So to multiply a monomial and a polynomial, simply distribute the monomial to the polynomial. For exponents, we need to recall that product rule. Remember, that product rule is if I have x to the power of a times x to the power of b, that's the same as x to the power of a plus b. We just have to add those exponents if we're multiplying the bases. First, we always have to distribute. So here I would be distributing the x to each term in the parentheses. So x times x and then x times 4. X times x is going to give me x squared because they each have a power of 1. I'm adding those exponents for that product rule. X times 4 gives me 4x. We also need to make sure they're always in standard form when we're finished. I go from descending order of degree 2 to 1, so that works. Here, I'm going to do the same thing. I'm going to distribute to each term. There's 3 terms in this parenthesis, so it's a trinomial. So I'm distributing this monomial to each term. So 5m to the power of 3 times 3m squared. I'm doing that 5 times 3 first to get 15. M cubed times m squared, I'm adding those exponents to get m to the power of 5. Then I have 5 times negative 1 to get negative 5. I have m to the power of 3 times m to the power of 1, adding those exponents to get m to the power of 4. Then I have 5 times negative 7. That's going to give me negative 35. And that m cubed is just essentially multiplying by a 1 if there's no m here. This is in descending order of degree, 5, 4, 3. So we are all set with that problem. Now for these problems here, there's quite a few of them. I'm going to do every other odd problem. If you want to try to do the other, like I'm going to do numbers 1, 5, 9. You could be trying 3 and 7 at home. I am going to post an answer key to the ones I don't do in case you want to try any of them. If you want to do the evens too, those will be on my answer key too. Whatever you want to practice at home. But I would just like you to do the odds that I do not do for homework so that you can practice these a little bit. So here I'm going to distribute k times k gives me k squared, and k times negative 9 gives me negative 9k. This monomial has to multiply by every term inside those parentheses. Moving to number 4, negative 4g squared needs to multiply by each term. So negative 4 times 2 is going to give me negative 8g to the power of 3. I'm adding those exponents. If there's no exponent on the g, it's just a 1. So 2 plus 1 is 3. Negative 4 times 7 is going to give me negative 24. I'm sorry, negative 28. Okay. And then I have g to the power of 2. There's no g here. So that g squared is just essentially multiplying by 1. Number 9, I have a lot of p's and q's here. They are not like terms unless they have the same exact exponents. Just keep that in mind as we simplify. This is a term, this is a term, this is a term. This monomial is multiplying by each term in the parentheses. So the p will multiply by the base p. So p's and p's are going to multiply bases. If they have the same base, so they both have a base of p, I can add the exponents. So p squared times p to the power of 5. I'm adding that 2 and 5 to get p to the power of 7. Q cubed and q squared, I can add those 3 and 2 to get q to the power of 5. Then I'm doing it again here, p squared. And notice I'm multiplying a positive 1 times a negative 1, so I'm going to have a negative here. P squared and p to the power of 1, that's going to add to be p to the power of 3. Q to the power of 3 and q to the power of 1 is going to be q to the power of 4. And 13 here, I'm multiplying this by each term in the parentheses. So negative 7 times 9 is going to give me negative 63. I'm starting with the c's. Okay, c cubed and c squared. I'm adding 3 and 2 to get c to the power of 5. And then my d squared and d squared will combine to be d to the power of 4. Just adding those exponents. Then I have to multiply that term by this one. So negative 7 times negative 4 is going to give me positive 28. Negative times a negative is a positive. I have c to the power of 3 and c to the power of 1. So that's going to give me c to the power of 4 and d to the power of 7 when I add 2 and 5. Okay, moving on to the back. These are going to get a little harder now as I go through 17 and 21 because there's just a little bit more going on. There's multiple distributions happening. And we have some lone terms, like this negative 9y is by itself. It's not being distributed at all. It's not inside of parentheses. So first I'm going to take care of this distribution, then I'll move to that one. So y times y gives me y squared. Y times 4 is 4y. Now I'm going to distribute here. Negative y times y gives me negative y squared. Negative y times negative 3 is going to give me a positive 3y. And then this negative 9y just comes down. Now I'm going to combine my like terms. I have y squared and negative y squared. That's the highest degree I have, so that's why I'm starting with the squareds. Starting with that degree of 2 because it's the largest. Those actually cancel because it's a positive 1 and a negative 1, so they add to be 0. Now I'm left with 4y, 3y, and negative 9y. 4 and 3 add to be 7. Minus 9 gives me negative 2y. And that's my final answer. 21, it's got a little more going on. Okay, so I'm going to take care of each distribution at a time. Okay, I'm going to start with this one. 3v times 7v is going to give me 21v squared. 3v times negative 2 is negative 6v. Now I'm going to tackle this distribution. 3 times v squared is 3v squared. 3 times 2v is 6v. 3 times 1 is 3. Now to tackle this last distribution, negative 3v times negative 5v is positive 15v squared. And then negative 3v times 3 is going to give me negative 9v. Now I'm not done here. I've got to put everything in standard form. So I'm going to start with my highest degree, which is those degrees of 2. So I'm going to combine 21 and 3 to get 24, and then combine that with 15 to get 39v squared. I like to cross those out just so I can see what else I have left. I have negative 6v and 6v. Those cancel. Those add to 0. Negative 6 plus 6. I'm left with that negative 9v. And then I bring that 3 down. It has no like terms. Okay. Last two problems I want to do with you guys are these application problems where we have actual pictures where we can apply our multiplying polynomials. So first we're going to be talking about area. So we have area of trapezoids in this problem, and we have area of rectangles / squares. So for area of a trapezoid, we do area equals 1/2 height times base 1 plus base 2. For a rectangle, it's just area equals length times width. So we're going to use those formulas to help us with 25 and 26. So the first one says to find the area of the trapezoid. This is our trapezoid. Everything's labeled for us. So if area equals 1/2 height times base 1 plus base 2, I have 1/2 times the height, which is 4x squared, times the base. Well, it doesn't matter which base we call it. I'm just going to use the top one first. 8x squared plus 3x plus 2x cubed minus x. So I'm using that bottom base. I'm just adding those two bases together. Now I'm going to multiply these times each other. So 1/2 times 4x squared, it's going to give me 2x squared. And I'm just going to simplify everything in this parentheses. So I'm going to put it in standard form as well. So 2x cubed would come first, has no like terms. Then the 8x squared, that's the next highest degree I have, has no like terms. And then I can combine this 3x and negative x to give me 2x. Now I'm just multiplying this monomial by this whole polynomial here. It has 3 terms, so it's a trinomial. So I'm doing 2x squared times this 2x cubed first. That's going to give me 2 times 2 is 4. And then my x's, I have x squared and x cubed, so I'm adding those exponents, 2 and 3, to get x to the power of 5. 2 times 8 is going to give me 16, and then x to the power of 4 when I add those exponents. Lastly, 2 times 2 is going to give me 4, and now I'm going to get x to the power of 3. Okay. This is all already in descending order of degree, 5, 4, 3, so we're all set. Now the last problem asks us to find the area of a shaded region. They mean this gray area here. So we want to take this little box or rectangle out. If we're trying to take the rectangle out, think of it as I have a piece of paper and you want me to cut this piece and remove it. So you want to know the area of everything except for that piece, if that piece is removed. So the way we find the area of a shaded region is we do the area of the outside minus the area of the inside. So remember, area for a rectangle is just length times width. So I'm going to do this big area first. So I'm going to put it in a big bracket, and I'm going to do length times width. So 6x times 8x minus 1. And I'm subtracting the area of the inside. So I'm going to have big brackets again, and I'm taking the area of this smaller rectangle. 2x times the length, 5x plus 3. I'm going to do what's inside these brackets first. So I'm going to multiply here. 6x times 8x gives me 48x squared. 6x times negative 1 is negative 6x. And then I'm going to subtract, but I've got to solve for what's inside this bracket first. So I have 2x times 5x to get 10x squared, 2x times 3 to get 6x. Now, this is taking it back to last week. We're just subtracting 2 polynomials. So I'm going to rewrite the first parenthesis. Everything in the second parenthesis, I'm changing the sign because I'm subtracting. So I'm changing this to be a negative 10x squared and a negative 6x. And now I'm just going to combine like terms. These are like terms as they're both to the power of 2. So they're going to combine to give me 38x squared. And then negative 6x and negative 6x gives me negative 12x. So this would be the area of my shaded region. Okay, if you guys have any questions with this, please don't hesitate to ask. Remember, you are doing every odd problem that I did not do today. So the odd problems that I did not do would be numbers 3, 7, 11, 15, 19, 23. Okay, so not too many problems. I just want you to try those on your own at home. And next class, we will dive deeper into this. So if you're really struggling with this today, don't stress too much, but try your best. Okay, have a wonderful day, guys.